Welcome. This video is going to introduce the concept of the queue abstract data type. The queue is a relative of the stack. It has some commonality with the stack, but it's different. A queue is a data structure that organizes elements into FIFO order, as it's called. You might remember a stack was LIFO, last in, first out. Queue is FIFO, first in, first out. And that corresponds to a line of people when we obey kind of the convention of a fair line. So on the right here is a picture of people in line. And the way that a line works when everyone's being polite is new people go to the back of the line, and when someone is ready to get served or taken or whatever, they come out of the front of the line. So whoever's been waiting the longest goes first. So we call that first in, first out. And I'll note that in British English, the phrase for in line is on queue. In American English, the way I would say it is that these people are in line, but in British English they say that those people are on queue. They use this exact same word queue that we use for our data structure. Note the spelling, it's a bit of an unusual word, queue. The spelling is the letter Q and then U-E-U-E. So you're going to have to write this word queue a bunch of times. Keep in mind that pattern, Q-U-E-U-E. Let's formalize the operations on a queue. There's enqueue, which is given an object x, and that adds element x to the last position at the back of the line. Front is an accessor that returns the element at the first position at the front of the line. In order for that to work, the queue has to be non-empty. You can't get the front of an empty queue. And dequeue removes the element at the first position. This is how we shorten the queue or shorten the line. The person at front is removed from the queue. And again, the queue has to be non-empty for that to work. Here's how we would sketch a queue. So we'll sketch a queue in a pretty simple, high-level way. It's a row of boxes. Each element is in its own box or rectangle. The front element is to the left, and this is implicit. We don't label the front necessarily. It's just implicit that we put the front of the queue at the left and the back of the queue at the right. This corresponds to how we read English and some other languages, where you start on the left and move your way right. So if I wanted to sketch a queue that contains 6, 5, and 7, where 6 is at the front of the queue, I would draw it like this. 3 rectangles with 6 on the left. That means that 6 is at the front. Let's just go through an example of executing some queue operations and sketching the result. If I create an empty queue, there's nothing to draw, just emptiness represents an empty queue. I'm going to work with the computer science security first names. There's this convention in security when you're talking about agents in some security system, you use peoples whose first names start with A, B, C, and so forth. So let's enqueue Alice, that's the first one in that list. Here's my queue that just has one element, the string Alice. If I enqueue Bob, Bob will go to the back of the line on the right. There's Bob. If I enqueue Carol, Carol goes to the back of the line on the right. So now I have 3 elements in the queue. If I dequeue, we remove the front element, which would be Alice at this moment. It's Alice's turn, so Alice is removed. If I enqueue Diego, he goes on the right there at the end of the line. If we dequeue, then Bob goes away. And if I dequeue one more time, then Carol goes away. And that's it. That's where we're left at the end.